Good morning, my dear students. Once again, we are continuing that P block chapter, lesson number 2. So yesterday we started about the 14th group, that's carbon group. So in the carbon group, those elements are having catenation property. After that, carbon in particular is having 4 allotrophic forms. It has graphite form, diamond form, and then fullerenes, then graphene. So these are the 4 allotropical forms. So yesterday we discussed only about the arrangement of the carbon atoms in the graphite allotropy. Today we will see the other 3. So the next one happened to be diamond. Okay, so diamond is the costliest material in the world. It is made up of carbon atoms only. It's a very hard, it has got a huge density, it is a very hard material that is being formed. And the carbon atoms in diamond is found to be sp3 hybridized. We know that carbon has got 6 electrons. So in the ground state there are only 2 unpaired electrons. When it is taken to excited state, it gets 4 unpaired electrons. And all these 4 electrons will undergo hybridization, and it is called sp3 hybridized. So sp3 hybridized will have what shape? Tetrahedral shape, right? That is a very important function of this carbon. So all the carbon atoms will be placed tetrahedrally because the hybridization is sp3. Every carbon atom will make bonds with 4 other carbon atoms in tetrahedral shape, right? And since all the 4 valency electrons, all the 4 valency electrons are involved in the bonding, there is no free electron to conduct the electric current, right? So this is the extraordinary situation that we see in this. Whereas graphite can conduct electric current, but diamond cannot conduct electric current because there is no mobile electron or free electron or delocalized electron or pi electron in the diamond allotropy. It has got all the 4 electrons completely fixed in the bonds. They have tetrahedral arrangement. This is almost the arrangement of the carbon atoms, right? So it will go, the hexagonal shape will go like this, and it will be connected in all the 4 directions with 4 other carbon atoms. So one carbon here, another carbon here, third carbon here, fourth carbon with the next unit. It will go like that, right? So as far as diamond is concerned, it is used for sharpening the tools because it is very hard, right? It is used for cutting glass. Have you gone to any glass shop? Or you know how they are cutting glass? They will be having a pencil with a tip which is made up of diamond. So they just draw a line and press it and the glass will cut. That's how glass are being cut, right? For cutting glass, diamond is used, and for making the bores, right? In the land also, this diamond is used, and rock drilling in the mines also done using diamond only. So this is the some of the features of the diamond allotropy. The next allotropy is fullerenes. So fullerenes are not natural allotropy. That's a very important factor. Graphite and diamond occur in nature, but fullerenes do not occur in nature. They are synthesized in the lab. They are chemically prepared allotropy. Therefore, it is a synthesized allotropy, right? It has got number of discrete molecules, different variation in the molecules. There are carbon 32, carbon 50, carbon 60, carbon 70, and carbon 76 are some of the examples of these molecules. They have cage-like structure, right? They are closed packed cage-like structure. For example, the carbon 60 is like soccer ball, football, and it is also called as Buckminster fullerene, right? In this carbon 60, 20 6-member ring will be present and 12 5-member ring will be present. What is a 6-member ring? This is the 6-member ring, right? There will be 6 carbon atom in the hexagonal shape. Like this, there will be 20 in the carbon 60 fullerene. And what is a 5-member ring? 5-member ring will be like this. It is pentagonal shape. So this will be alternately placed throughout this soccer, and if you count, it will come to 20 will be 6-member ring and 12 will be 5-member ring. So this is how the structure of this carbon 60 fullerene is being found out. But as far as the carbon atoms in fullerenes are concerned, they are sp2 hybridized and they have formed 3 sigma bonds, and there is 1 pi bond with a delocalized electron, and therefore this is having what character? Aromatic character, right? None of them have aromatic character. This is the one which will have aromatic character like benzene. The carbon-carbon bond length in this will be 1.44 Armstrong, whereas carbon-carbon double bond length will be 1.38 Armstrong, right? So using these fullerenes, we have even the carbo nanotubes, which will have graphite-like tubes, and the ends will be having fullerene structure. They are found to be very strong when compared with the steels, and they are used in making the nanoscales, polymers, and medicines, and so many industrial applications, right? So that's about these fullerenes. And finally, we go to the graphenes. Graphene is also synthesized allotropy, right? It exists as a single sheet. In this also carbon is sp2 hybridized. So when you say sp2 hybridized, only these two will be involved in the hybridization, and 1 s orbital, 2 p orbital will undergo hybridization. The sp2 hybridized, right? This is a densely packed honeycomb crystal, right? What is honeycomb? Right? தேன் கூடு மாதிரி இருக்குமா? அது இந்த மாதிரி இருக்குமா? தேன் கூடு மாதிரி ஒரே சிங்கிள் ஷீட்ல அப்படியே படர்ந்து தேன் கூடு பார்த்துருக்கோம் இல்லையா? அந்த மாதிரி இதுல this hexagonal ring will be closely packed and they will be placed in the graphene structure, and this is also used in making number of industrial applications, right? In the industries, right? So these are the 4 allotrophical forms, right? So first is the graphite. Between graphite and diamond, you must be even able to make a table. What are the differences between graphite and diamond? Maybe fullerenes, they'll ask separately about the study about that. And after that, we have these graphenes. Graphenes, a small information is only given in the book. So these are the 4 allotrophical forms of carbon. Right? After that, we are going to study about 2 carbon compounds only. That is carbon monoxide and carbon dioxide. After that, we are going to the compounds of silicon and silicates. With that, we'll wind up this chapter. So tomorrow we'll see carbon monoxide and carbon dioxide. Okay. So keep yourself busy in studying. We are able to get the portions to be deleted. Therefore, we'll keep giving. And the second volume book is also now available. We'll find out when you can come and collect it from the school. Stay safe. God bless you.